From a group of 5 males and 6 females, 4 people are chosen. A. Determine how many possible groups can be chosen. It's a number of combinations 4 out of 11. 4 because we need 4 people. 11 because there are 11 people in total. Why is it a number of combinations, not permutations? Because we choose indistinguishable people and order doesn't matter here. If it would be given that we additionally distribute some duties between them, for example, to be a player number 1, number 2, number 3, number 4, so that this problem becomes there are combinations 4 out of 11 ways to choose such groups, but for each group there are 4 factorial ways to rearrange them due to be a player number 1, number 2, number 3, number 4, and it's a number of permutations 4 out of 11. But when an order doesn't matter, we choose indistinguishable people. It's a number of combinations, not permutations. So we need just calculate it. We can use a calculator. A formula is also given in a data booklet. So it becomes 11 mass combinations for, and we get 330 possible groups. B. Determine how many groups can be formed consisting of 2 males and 2 females. So we need to choose 2 males out of 5, and again it's a number of combinations 2 out of 5 multiplied by a number of combinations 2 out of 6. It's a multiplication because it's and like one event, and we need just calculate it. 5 mass combinations 2 multiplied by 6 mass combinations 2, and we get 150 possible groups. C. Determine how many groups can be formed consisting of at least 1 female. And usually at least 1 can be calculated as the total number of ways minus the number of ways to get unwanted groups or events, and the total number of groups, it's number of combinations 4 out of 11, and the unwanted groups are groups which consist of no females, and it means all males. So we need to choose 4 males out of 5, and it's a number of combinations 4 out of 5, and it becomes 330 minus, and there is such a property that a number of combinations k out of n is equal to a number of combinations n minus k out of n. Hence a number of combinations 4 out of 5 is the same as a number of combinations 1 out of 5, and 1 out of n is just n, so it's just minus 5, or you may use a calculator. So it becomes 325 possible groups. Another way to solve this problem is to consider a group which consists of 1 female and 3 males, and the number of ways to choose such groups, it becomes number of combinations 1 out of 6 multiplied by number of combinations 3 out of 5 plus 2 females, 2 males. So number of combinations 2 out of 6 multiplied by number of combinations 2 out of 5 plus 3 females, 1 male, so number of combinations 3 out of 6 multiplied by number of combinations 1 out of 5 plus, and 4 females, so number of combinations 4 out of 6 multiplied by a number of combinations 0 out of 5, which is 1, and it's 5. And if you calculate it, you get the same answer, 325 possible groups. And that's all for this question.